you are still welcome to our channel, uh, where we had the discussion, or let's say a little introduction on solar system component. If you can recall, where we stopped yesterday, we were discussing about solar panel, how to identify the capacity of solar panel in case if the nameplate is no longer there. How do we do that? I said we have many ways to achieve that. How? Using physical appearance by what? By counting the total number of cells, starting from number one to the last cell. If you can recall, in the last video, in the introductory part of it, we had on the horizontal axis we had four cells, where at the vertical axis we had 18 number. So which means if you multiply 18 times 4 and then we choose either minimum of 0.5 of a certain voltage, we attain to a particular voltage, or if we select 0.6, we also attain a particular VOC, total VOC. This 0.5 or 0.6, we are not the one to what determines whether we have to go for a minimum of 0.5 or maximum of 0.6. But who is responsible for that is the manufacturer of what? The solar panel itself. So now, for instance, if we are to maintain, let's say 0.5 as our what minimum of circuit voltage, this is how the formula we are going to use. Total VOC, which is total of circuit voltage. We say, okay, since each cell is capable of producing minimum of 0.5, if we take the minimum, which means we'll say 0.5 plus 0.5 plus 0.5 to the last number of what? Cell, which is 0.5. So if you are with me, we are to say 4 by what? 18, correct? And then whatever we have, we multiply by 0.5. Of course, you believe me, we are going to have 43 point what? Point something, which means according to our previous open circuit voltage, it indicated that it is what? 44.22. Meaning, this manufacturer has considered minimum of what, maximum of what? 0.6 at the open circuit voltage. Okay, fine. If maybe we obtain, let's say 43.3 VDC. DC is the direct current. We are dealing with DC current from solar panel, the charge controller, the battery itself, and half of the inverter. Because in the inverter convert direct current into alternating current. Even though, let me not just jump maybe faster than my leg. Let me just maintain where we are. All right. Okay. So now, since this is our total VOC, then how do you obtain the current? Because I said we are to determine power output of the solar panel in case even if the nameplate is not there. Simple. That's why I say we need the measuring instrument, right? Okay, now, which means we can what? Deploy the use of what? Clamp meter to measure what? Current. But in this case, we are only measuring the short circuit current. Why? Because we only obtain maximum power current when we connect our panel in the system. And then through the charge controller, then we have what we call maximum power current. Or we use this meter. And that is why I love this meter. You see, I love this meter because I don't have to use charge controller before obtaining my maximum power current. Please don't be carried away. We'll have a session where we are going to what? Do the measurement. You will see it practically on how to obtain all these parameters that I mentioned earlier, right? Okay, so now for instance, I don't have this meter with me, so which means I can what? Manage to use the clamp meter to obtain the short circuit current of the what? Solar panel. But mind you, I'm not encouraging you to what? To short circuit the terminals of what? Your solar panel. Because you can only short circuit solar panels if it is maybe 1 or 2 or 3. The higher you go in the connection, the more dangerous the system will be. Why? Because direct current is very dangerous. Because it is moving in a direct way, like this. You see, this is how it is, you know. continuously, the current is moving. Whereas if you are using alternating current, this is how it is. You see, if this is on, this is up position. So which means if you are electrocuted on AC system, by the time it is on position, you are still active. But anytime it is under off position, you can disengage yourself. You see, at least it is safer than what DC. But direct current, if you are dealing with higher voltage, which means there is no breakage, and it's very dangerous. So we are going to measure the short circuit current on what the from the terminal of the solar panel. How do we do that? We short the what? The polarities, just like this. These are the polarities, right? For example, these are the polarities. We clamp this way. Did you hear this sound? Clamp. Meaning there is contact between positive and negative. Then you select from the meter what voltage, current are you dealing with? Is what? If you can remember, our current, maximum power current is what? 11.11, and then short circuit current 12.99. Okay, so let me take, okay, I will select DC here, DC amp. Can you see it? DC. So it's all right. So which means I will clamp from here. So immediately I clamp it. This is how to what? Measure current. Immediately I clamp it, it will indicate the current to measure it. As you can see, it will indicate the current, which means you take note of the current, even though now we are not going to get anything. Why? Because it is not engaged, and we did not what power our solar panel. But don't worry, we are going to have a session where we are going to what measure the parameters of solar panel, and then we see what are the factors affecting the performance of what solar panel, and at what angle are we supposed to what orient or tilt our solar panel, and what orientation. What I mean by angle, there is what we call angle of inclination, and there is an orientation where you are supposed to what face your solar panel so that at least you'll be getting the maximum power from the sun. Okay, so now by obtaining the current, for example, maybe if we are 10, let's say 10 amps, just take it for example. So for us to get the power, we say, okay, power is the product of what? Current and voltage. And this is the current obtained from the meter. Even though it's a what? Short circuit current, we say, okay, which is equal to 10 times 43.3. Which means we'll have 430.3 watts. If you can remember, the panel we used out there is what? 450 watt. Can you see? We are getting closer to the capacity of the power. All right. So which means even though there is no nameplate, we can be able to what? Know the power rating of what? Our solar panel. And then we will obtain the other parameters. And using this meter, in our next class, we are going to what? Measure those parameters, see the factors affecting the performance of solar panel, and at the same time, what? Measure the tilt angle and orientation of the solar panel. Okay, fine. So now let us go back to our what discussion. So what are the categories? What are the types of solar panel? We have about 3 types of solar panel. We have monocrystalline solar panel, we have polycrystalline solar panel, and amorphous. We have number 1 types of solar panel. Number 1, we have monocrystalline. Number 2, we have polycrystalline. Number 3, we have a thin film / amorphous. These are the 3 types of solar panel obtainable. Okay, what is monocrystalline? What is polycrystalline? And what is thin film? Monocrystalline solar panel is the best, or let me say, is the one that is having the highest efficiency among the 3 types of solar panel. It has a filament pattern, just like this. which means it has a diagonal shape. For you to identify it, it has a small diagonal shape like this. Sometimes it comes either pure black, sometimes it comes maybe in bluish in color. And at the same time, we have different type. It can be foldable. It can be what? Bifacial. What I mean by bifacial, both top and bottom, there is an existence of what? A source. Why do they consider the bifacial? Bifacial in the sense that you see we have three radiation falling from the sun within the atmosphere of the number one, we have direct radiation, we have reflected radiation, and we have scattered radiation. So which means if the top one is receiving the three, direct, reflected, and diffuse, which means the bottom one can be able to what? Access the reflected radiation and what? The scattered radiation, which is moving around the air. So which means the performance of that particular solar panel will be what? Very, very higher. Okay, so now, which means this monocrystalline solar panel has pyramid pattern, like it has a diagonal shape, small cut. But don't be carried away. Nowadays, we have a monocrystalline solar panel that is having a very small shape pattern. So it is also a monocrystalline solar panel. Alright? Of course, anything that has advantage, we must have disadvantage. Of course, despite the fact that it has higher efficiency among the remaining three, but it has one factor that is affecting its performance. What is it? That is high temperature. Because we have three factors affecting the performance of what? Solar panel generally. We have high temperature, we have shading, and lastly we have dust. Now, within these three, if anyone arises, definitely the performance of the solar panel will what? Reduce. As such, high temperature do affect the solar panel if it is monocrystalline. So that is why it is best to be utilized in a position or in an organization, or let's say in an environment where they are having less temperature. Which means if the temperature is not high, that place is better to be what? To utilize the monocrystalline solar panel. Then the next one is polycrystalline solar panel. Polycrystalline solar panel is the one next to solar for the monocrystalline solar panel. It has the efficiency of up to 14 to what? 18%, whereas monocrystalline has 16 to 18%. So which means the difference is only 2. But one beauty part of polycrystalline solar panel, it can withstand harsh weather. This is the diagram. Okay. Unlike the monocrystalline solar panel, it has what? A regular interval. A regular interval. While the monocrystalline has pyramid pattern or rectangular, shape. All right. Okay. And both the panel has a lifespan of what? 25 years. Depending. You see, we have a grade A, grade B, and grade C. So if you have a grade A solar panels, generally they are supposed to last for 25 years of what? Utilization, except in a situation whereby they were what? Mismanaged. Either maybe children played with it, maybe or somebody used a stone to strike on it, or maybe somebody during maintenance, out of ignorance, he marched on it and what have you. So that is the only possible reason where the panel will have an issue. And lastly, we have the amorphous solar panel. Most of the times, it comes either dark ash or brown in color. This is a list among the three types of solar panel. Of course, where do we normally use this type of solar panel? Most of the times for irrigation purposes. And if you can remember, there is a calculator that has no battery. If you experience at the top layer of it, you will see a small cell, brown solar cell, that is amorphous for you. That calculator uses what? The amorphous solar cell for it to function, which means without battery, it can function. So I think we are going to close for the day till next week. Then we'll see the remaining part, that is factors affecting the performance of solar panel, and then how to measure the parameters, and also the configuration, how to do connection on the solar panel. See you next. Thank you very much.